Nowadays, currently, AI workloads are expected to account for 70% of this global data center demand. It's growing like anything. So just to start with, what future advancement or the growth trends or chip designs can shape the future of data center liquid cooling adoption? Let's just start with Mr. Ashwin.
Sure, Mr. Gopal. Thank you for the question. So, of course, this is a very, very dynamic, dynamic space. It's changing very rapidly. Of course, right now, the best technology we have, which is commercially deployed at a large scale, is the cold plate direct to chip deployment. I think that's currently the best one. Of course, immersion cooling is out there, but it has commercial limitations to be deployed at a large scale. So that's a challenge. Now there are other technologies which I know of. Microsoft is working on one, which is basically microfluids. Now, what we understand is that Microsoft is doing a pilot where they've built chips which have micro capillaries, the way we have blood capillaries. So the chips have embedded micro capillaries wherein the fluids can actually go in, and instead of cold plates, those are much more efficient because you're really rejecting the heat directly from the chip rather than using a cold plate which sits on top of the chip. So that's one big technology trend that we are seeing. And now, of course, we'll have to see how commercially viable this is, because at the end of the day, if the capex drastically goes up, we really don't foresee a lot of operators to be picking up such technology. So at this point, we still have direct to chip. We foresee that we will move from single phase to two phase in due course of time. As companies like Nvidia and AMD and Huawei keep coming up with very high density, rather high compute chips. But that's one technology I can talk about, which I know. I mean, the rest I think we need to all keep an eye on and see how the space evolves.
Yeah, thank you very much. That was a revealing fact you told about the chip designs. Coming to Mr. Vishal Jadhav, what growth trends and the chip designs will shape the future of data center, though CapEx is also involved massively?
Sorry, I missed the initial part. What?
What future growth trends or the changes in chip design or the changes in chip designs will shape the future of data center liquid cooling adoption?
Yeah, so that is, as I explained in one of my slides, it is very evident that the future loads, thermal loads on the data center are going to be exponentially high. And Nvidia is launching chips one by one, one by one. So they have various computational powers, various thermal power density, and all those things. The major, what you say, the trends that are going to be, or major drivers that are going to be effective is all these cryptocurrencies mining and data, or all these chat GPT, copilot. Whenever there is a computational power which is high relatively to traditional data centers, that will require the highest heat, that will create a highest heat, and which will require the more cooling for that.
Yes, Mr. The traditional data center require much heat. Coming to Mr. Ravikumar Sahu, what are your views about the growth trends? Shall we go for the chip design, which will shape the future of data centers for the liquid cooling adoption?
So, as you see, as of now, we have two types of liquid cooling: your DCLC and your immersion cooling.
Right.
DCLC basically used, you can say, prime first mover. You can say anybody who is using conventional data centers, they can move to. They have a 40, 50, 60 kilowatt of the rack densities, so they can move up easily on that platform. And from a server's point of view, server OEM's point of view, also it is not much that challenge, okay, because it has some air cooled and liquid cooled component. But when we go to higher chip densities, you can say 1.2 kilowatt per chips kind of thing. So means your cooling has to be different. Means your means you have to shift to immersion cooling. So when it comes to immersion cooling, then whatever your storage or these memories, these are has to be different. This has some different racks has to be arranged, which stores these passive parts, or you can say which requires air cool part. Okay, so design point of view, we can say future chip design point of view, we can say, as we see, we are going means as you see, Nvidia is launching 600 kilowatt per rack. They are talking about such kind of load, but yeah, that is for innovation point of view, that is fine. But if you see operational point of view or the feasibility point of view, we can go means 70, 80 or 100 kilowatt with the help of means of 120 kilowatt per rack with the help of your immersion cooling, which I can see, which can be a very soon normal in coming 3 to 5 years. Uh, this may be the pictures, but in some special cases, you can say we can go from the proof of concept kind of projects, we can go up to 200 or 250 kilowatt per rack.
Oh, that's quite knowledgeable. Uh, See, data centers are increasing. Okay. And you are talking about the immersion cooling most of the times. And you talked in your discussion also, you talked about the air cooled and liquid cooling. Liquid cooling preferable for the most heat generating systems, right? So, Mr. Ravi, I want to know among the direct to chip versus immersion cooling, which offers the better balance of efficiency and scalability?
So, talking to it's direct to chip and this immersion cooling. So both has advantage and some has challenges as well. So
Mhm.
talking about the DCLC, or we can say direct to chip. So this is you can say easy to shift to the liquid cooling because in your conventional data centers, if you wanted to move to this thing, let's say 4 5 racks you want to convert into liquid cool, you can do that with some modification in your chill water systems. uh, but if you want to you want to go to immersion cooling, that will be a complete different change you required. So from transitional point of view, your DCLC will be the best choice. Coming about your efficiency point of view, uh, sure, immersion cooling has no water content, no and no air part, air cooling. So basically, whatever the air cooling we use in DCLC, that will not be used in immersion cooling. So you that air cooling portion or power saves. So your PUE value for your direct to chip will be about 1.5 to 1.05 to 1.0 1.1 in that range. But your PUE value of your immersion will be lesser, 1.03 to 1.05. So from efficiency point of view, immersion cooling is fine, but you need to see other perspective, how it works with your this transition or your challenges or your service design, all these things. So in a nutshell, or scalability, most thing is bigger thing is scalability. So in a nutshell, you can say your direct to chip can be better solutions, or in terms of your scalability, your transition point of view, your PU value. So but if you specific talk about the energy consumption or efficiency point of view, your immersion cooling is best choice as of now.
Okay, thank you very much for sharing your viewpoints. Mr. Ashwin,
Yes.
definitely. Coming to Mr. Vishal, uh, uh, just now Mr. Ashwini was mentioned ki for different cooling and different systems, different mode of cooling is required. And you are also talking about the different cooling for different application in your presentations. So what may be the biggest hurdle to scaling the immersion and liquid cooling across global facilities, the big data centers?
Right. So as I said, scaling up to that level will the only thing which will take that level is high computational power. Those are not traditional, storage type of data centers. But whenever there will be, usage of AI, ML, and those kind of things, there will be an immense requirement for data center to scale up their capability to service that need of the customer. So as Mr. Vijay was saying, even if you are typing good morning to ChatGPT, it consumes a liquid. So storing some data is sufficient enough for air cooling to handle that. But if there is a computational power that a server adopts or chip is adopting, let's say some online game, even this PS5, all the games which are there, it requires a lot of computational power to generate that sort of animation and logic and difficulty level and all those things. And that's where I see the moment that usage goes up over the internet, these things will definitely take up precedence.
Users and data would keep on increasing in the coming future. Mr. Ravikumar, are you there? Hello, Mr. Ravikumar.
Yeah.
Yes, sir. Sir, coming to you, of what liquid cooling strategy approach for the existing data infrastructures can optimize the heat management? Because already retrofits things are involved, cost is involved, and so many carbon neutrality is also involved. So what cooling strategies approach would be the better in this scenario?
So cooling strategies means will not be same for everyone. You can say it will be different for a hyperscaler, it will be different for colocation, or it will be different for enterprise business. So
Correct.
coming to this liquid cooling strategies, everybody is all aware that AI will come into the pictures.
Yes.
Every businesses, maybe it's finance, manufacturing, anything. So slowly everybody moves to the whether it's a small business or a mid-sized business, they will go to the AI or high density loads. Okay, so for hyperscaler, we can say who they want, they are a very big scalable infrastructure. So uh, they can and it's a very specific customer specific, so they can move easily to either your immersion cooling, because they have a targets for your low PUE, because they have involved in some sustainability agreements or some this kind of agreements they are globally working. So for PUE value, for water usage effectiveness, or your heat use potential. So looking at these three or four things, hyperscalers can move easily to this immersion cooling. Talking about the co-locations, so co-locations has to be for which can be can cater all the requirement, because for render purpose, so means they can have a enterprise business as well as some colo cloud customers. So for them, the best thing can be they can slowly adopt to direct to chip liquid cooling, because it is easy for them to transition to that phase. And with the help of this, you can have in any let's say a co-location in any floor, you can have some space allotment to the your air cooling part, and some to this liquid cooling. In that way, they can in a given space, they can cater to different customer. Enterprise businesses, you can say slowly they will shift to liquid cooling, but as of now, they can start their working or POC kind of projects. They will they start working on that first to check how it works, everything. Then once they get the confidence, slowly they will adopt to this. So in that, I will in my opinion, so this cooling strategies will be different for different players based on their objectives or their this thing. So yeah.
Yeah, thank you very much for sharing that perspective. Coming to the last question, Mr. Jadhav, just now, Mr. Ravikumar was mentioning about the AI is increasing. So whether AI and HPC workload will make the traditional cooling obsolete for high density racks?
My personal opinion is it will not be absolute. It will still be there. Right now, if you look at this, still maybe I was doing some research. Around 80%, 85% of the world's data center are still traditional air cooled data center, and liquid cooling is taking part. So that percentage will vary. I don't know how much it will vary, but yes, the presence of traditional air cooled data centers will absolutely be there. Because there is one more stage. I mean, I'm sure Ravi Kumar knows. Air cooling, liquid cooling, and then there is a rear door heat exchange. So rear door heat exchange is another form of air cooling itself, where you are taking liquid closer to the server racks. So even if you have rear door heat exchangers as a cooling methodology, you still need a air cooling for that hall. So it will definitely remain there as a part of it.
Correct. Yeah. Thank you very much for sharing that. What are your views, Mr. Ashwin?
Yeah, I would actually second what Mr. Vishal stated. I mean, frankly, uh, if we're just starting off, the reality is, at least in our region, we are still starting off. Just to throw a number to you, I think India current deployment is about 1.5 gigawatts as a country, and of that, only maybe 5 to 7 megawatts, which is like less than 3-4%, is really HPC or liquid cooling deployment, frankly. So it will definitely take a lot of time, and there will always be a mix of both, even if it skews towards HPC and AI. This is something which will evolve, but I agree with Mr. Vishal. I don't think it's going to go away.
Right, right. Thank you for that optimistic note. Mr. Ravi Kumar, may we have your views on this?
Yeah, so the question was whether this air cooling will be so yeah so
Make the traditional cooling obsolete for high density racks, whether AI and HPC workloads will
so
render traditional cooling
I
useless.
agree to a previous speaker on this. So
Right.
see, completely removal or completely extension is not possible in any case, because very soon means not every workload is in future. Let's say after 5 years also, not every workload will be all liquid cooling. There is a chance there may be a good number, a good percentage of air cooling is required. So still, if you see, we are offering rear door heat exchangers. So 50 kilowatt per rack, we are able to cater with the help of rear door heat exchangers. So, and we are have a solutions, we can cater 70 kilowatts per rack with the help of rear door heat exchangers. So talking to means completely removal or no, that is not possible. Maybe you can have a 50% coming coming 3 to 4 years, or maybe 50 60 more percentage of liquid cooling and 60-40 in that sense. But I do not see as of now, from seeing today, as of now, I cannot see this extension of air cooling after 3 to 4 years. It will continue to run. Maybe some liquid cooling is slowly progressing. So if you see from the requirement point of view, in every 10 requirement, we have a three, you can say 3 to 4 requirement is for liquid cooling as of now, considering all the different customer enterprise, hyperscaler, colo. So maybe last year this number was 2 out of 10, but this year it was, you can say 4 out of 10. So maybe next coming 2 years it will be 50% or 60-40%. So you definitely your liquid cooling percentage will rise, but air cooling will be there.
Thank you very much. Yes, as Mr. Vishal also mentioned, air cooling would be there to cool the rooms. And yes, it is increasing, and preference would be towards the increase in liquid cooling. So thank you very much, gentlemen.